This tutorial video will demonstrate how to take the name of a compound and determine its chemical formula. In order to do this, you have to recognize that the first half of the name of a binary compound is the positive ion of that element. The second half of the name is the name of an element with an "-ide" suffix. This "-ide" suffix means that the atom has taken on electrons and has a negative charge. And in order to determine the correct positive and negative charges on the two components, we have to look at the periodic chart and figure out how many electrons must be gained or lost in order to have a noble gas configuration. So in the case of calcium chloride, calcium is going to be the positive ion, and it needs to lose 2 electrons to achieve a noble gas configuration. So it has calcium 2+. Chlorine gains 1 electron, becoming the chloride ion. And in order to have a compound that is completely neutral, I will need 2 copies of chlorine, meaning that the chemical formula then is CaCl2. 2 indicates the 2 chlorine ions, balancing out the charge of the calcium. In the case of aluminum oxide, this works completely the same. Aluminum is the positive ion, and based on where it is in the periodic chart, we must lose 3 electrons, so it has a 3+ charge. Oxygen becomes oxide by forming its negative ion and picking up 2 electrons. And in order to balance this out, we will need 2 copies of the aluminum ion giving a +6 charge, and 3 copies of the oxide giving a -6 charge. And so Al2O3 is the correct formula. This works completely analogously for the other 4. Potassium forms a +1 ion. Fluorine becomes fluoride by picking up 1 electron. And in this case, it is a 1-to-1 ratio, so we need 1 potassium ion and 1 fluoride ion. For sodium phosphide, sodium needs to only lose 1 electron. Phosphorus must pick up 3. And in order to have this be completely balanced out, we will need 3 copies of the sodium and only 1 of the phosphide. Hydrogen is a bit unique in that it can gain 1 electron or lose 1 electron. And so in the case of hydrogen sulfide, what we have is hydrogen as the positive ion, so it will lose 1 electron. Sulfur becomes sulfide by gaining 2, and as a result, hydrogen sulfide is H2S. Magnesium hydride has magnesium as the positive ion with a 2+ charge, and hydride, because of the "-ide" suffix, we know that hydrogen gains an electron and becomes a negative ion. And in order to have this balanced and completely neutral, we have MgH2. And so here you have 6 examples of using nomenclature to, as I would say, translate from English to chemistry.